All right, so today we're going to talk about balancing equations. In order to look at that, we're going to look at the assignment that you will be working on for these next 2 days. And that assignment looks something like this. And you're going to do a PhET simulation, but then after that you're going to do some practice. We've already gone over some of the practice, but we went through the boxes, and this has a little bit more for you to practice. And I know some of you are still kind of iffy about it, but let's go ahead and see if we can work out some of the problems with it. All right, so the one that I'm going to choose to work with you is number 13. Okay, that's your cobalt 3 bromide reacting with calcium sulfate to produce calcium bromide and cobalt 3 sulfate. I went ahead and wrote it over here. Okay, and I also figured I'd get the boxes done and ready to go. So the way the boxes work is that every chemical formula will be a box. You just get the elements from that formula. So here's cobalt, here's bromine for this one. There's calcium, there's sulfur and oxygen. For this one over here, there's calcium, there's bromine, and over here there's cobalt, there's sulfur, and then there's oxygen. Okay, so you're going to go ahead and count the atoms and then write down how much you have for each one. All right, so we figured that we have 1 atom of cobalt, 3 of bromine, 1 of calcium, 1 of sulfur, 4 of oxygen, 1 of calcium, 2 of bromine, 2 of cobalt. This 3 distributes, so it's 3 of sulfur, and then 3 times 4 makes it 12 of oxygen. So as you can see, they're not balanced, okay, and that's what we're going to work on. So we start with our metals. No matter which metal you start off with, but since this one is here, we'll go ahead and start with cobalt. So this cobalt, there's 1 on the side of the reactants and 1 on the side of the products. So what I'm going to do is I'm going to go ahead and multiply that by 2. Okay, this 2 has to multiply with everything inside the box. So 2 times 1 gives me 2, and this 2 times 3 gives me 6. Okay, so now the cobalts are balanced. The next metal that I see is calcium. There's 1 on the reactants, 1 on the products. So those are good. Now we go to our nonmetals because we don't have any more metals. So the bromine is a nonmetal, and this one has 6 on the reactants, but 2 on the products. So I want to go ahead and make that into a 6. So I multiply that by 3 to make it into 6, but remember it's going to multiply with everything inside the box. So 3 times 1 gives me 3, and 3 times 2 gives me 6. Okay, so now my bromines are balanced at 6 and 6. The next nonmetal is sulfur. There's 1 on the reactants and 3 on the products. So I'm going to go ahead and multiply this by 3 so it could be the same. That multiplies with everything in the box, making it 3 calciums, 3 times 1, 3 sulfurs, and then 3 times 4, 12 oxygens. Okay, so that means that now my sulfurs are done. Hydrogens and oxygens go at the end, so the last one is my oxygen. There's 12 oxygens on the side of the reactants and 12 on the side of the products. So far I've gone through every single element that's listed on this equation, but now I'm going to go back and check that everything is balanced. So here I have 2 cobalts, 6 bromines, 3 calciums, 3 sulfurs, 12 oxygens, 12 oxygens. So it's all balanced. Anything where I did not put a number, I'll put a 1 because it won't change the value of the 2, the 3, and the 12 because anything multiplied by 1 is the same. So now I have my coefficients. I just put them up here. That's for that one. The 3 is for this one. The 3 would be for this one. And the 1 for that one. So that's my equation balanced. Alright, so I'm going to go ahead and do another one, but I'm going to do it slightly different. And this has a little bit less work, but nonetheless it shows the atoms and whatnot. So looking at number 14, okay, Okay, so what I did here is I went ahead and I put down the different elements that we have on that particular equation in the middle to kind of separate the reactants and the products. Okay, so I'm going to go ahead and count the atoms like I did for the other one. So there's 1 manganese, there's 1 hydrogen, and 1 iodine. For this side, it's going to be 2 hydrogens, 1 manganese, and 3 iodines. Okay, so we're trying to even them out just like we did before. Okay, I see that this iodine is 3. Everything else, well, the hydrogen is not balanced either, but our metal, which we usually start off with, is balanced. So then we go to our non-metal, which is iodine, and then our hydrogens and oxygens. So I'm going to go ahead and begin with the iodine. Okay, so this iodine is 3, so to make this a 3, I'll put a 3 here. By putting the 3 here, that makes the hydrogen a 3, and then it makes this iodine into a 3. Okay, so now we have the iodines balanced, but our hydrogens are not balanced and our manganese is not balanced. Okay, so the problem with the hydrogen is that this is an even number and this is an odd number. So what you're going to do is that you're going to try and make it into an even number. And the only way of doing that is to make this into a 6. So to do that, I'm going to have to multiply this 2 by a 3. So I'm going to put a 3 here, and doing that, that will multiply 3 times 2, making it into a 6. So I can go back and then change that to where I don't want that 3 anymore. I'm going to want a 6. So 6 times 1 gives me 6, and 6 times 1 gives me 6. Okay, so now for the iodine, I'm going to have to do the same thing on this side. So I'm going to go ahead and multiply this 3 by a 2 by putting it here. 2 times 1 manganese is 2, and 2 times 3 iodines is 6. Okay, so we're almost done. We have the hydrogens and iodines balanced, but the manganese is not. So what we're going to do is make that manganese into 2 like the right hand side. So then we're going to go ahead and multiply this manganese by 2 to make it 2 like the side of the products. Okay, that changes that into 2. So now if you look at your reactants and your products, they're both the same amount of atoms. 2 and 2, 6 and 6, 6 and 6. Okay, so that's how you would balance that using a little bit less work that's involved in the boxes. You can choose to use either one. It's up to you. Okay, so if you're in my pre-AP class, I'm going to ask you to go ahead and write from a word equation to a symbol equation, and this is what you're going to look at. Alright, so the one that we're looking at is number 7, where it says when dissolved beryllium chloride reacts with silver nitrate and water, aqueous beryllium nitrate and silver chloride powder are made. Okay, here we're going to separate it into reactants and products. Alright, so what I did is I went ahead and underlined the main formulas that we're going to have to figure out what they are. Okay, so on another sheet of paper, what I did is I wrote them out so you can see how they come to be. Alright, so here we go. That beryllium chloride is right here, and you're going to see that you're going to have to use your ion sheet. Okay, as you can tell, this is third period that's coming in, so when you guys watch this video, you're going to see just how noisy you guys are. Hi. Alright, so here's my silver nitrate. Okay, and again, using the ion sheet, here's silver, here's nitrate. Because they're the same, they cancel each other out. So that would be the formula. For the beryllium nitrate, which is right here, beryllium is a +2 charge, nitrate is a -1, so it's going to be crisscross. And so the beryllium will crisscross over here, and the nitrate with the 1, we never show it. Last but not least, we have silver and chlorine. Silver has a +1 charge, chlorine has a -1 charge. And so what's going to happen is that they cancel out and you're left with AgCl. So these are the 4 that we're going to use in our balanced equation. Alright, so there's a couple of things that I need you to keep in mind whenever you're writing this out. So when it says, so when dissolved beryllium chloride reacts with dissolved silver nitrate, we know that those two are going to be your reactants. It says in water. So this is kind of tricky because I could see where you guys might want to put water, but that is just telling you that it's dissolved in it. It's not part of the reaction. So it's not going to be included into your reactants. So then it tells you that aqueous beryllium nitrate, the word aqueous is just telling you the state of matter. Aqueous means that it's been a solid that is able to dissolve in a liquid, so it's now a solution, but nothing other than that. So you don't have to pretty much include it as part of the reaction. So it makes the beryllium nitrate and the silver chloride powder, and it tells you that that's what's made. So we're going to go ahead and write them down here.
Is this one nice?
All right, so whenever we write it down as an actual equation, this is what we're going to see. I went ahead and put the lines so that those are the places where you're going to put the coefficients. But there's your beryllium chloride. There's your silver nitrate right here. And this is the symbol, the yield symbol that separates your reactants and your products. You have beryllium nitrate and then your silver chloride. So now our next step is to balance it out. All right, so I went as far as to put down how many atoms there are, or counted the atoms for each one. So for beryllium, you see that there's 1. For the other beryllium on the side of the products, there's also 1. For chlorine, there's 2 on the side of the reactants, and then you'll see that there is 1 on the side of the products. Silver, there's 1. On the side of the products, there's 1 as well. For nitrogen, there's only 1. If there's not a number, it's understood as 1. And for the nitrogen on the side of the products, this 2 distributes inside the parentheses, so it makes 2 nitrogens. And then last but not least, you have oxygen. For oxygen, you have 3. And for the side of the products, this 2 distributes inside the parentheses, making it 2 times 3, and therefore getting a 6 for the oxygen. Okay, so kind of the same methodology. So you're going to do metals, nonmetals, and then your hydrogens and oxygens towards the end. All right, so my beryllium happens to be one that I could start off with. So is my silver, but as you could see, they're both balanced. So we're not going to go ahead and start with those. So then we go on to our nonmetals, which are our chlorines and our nitrogens. Don't forget that the hydrogens and oxygens are the last thing you do. So I'm going to go ahead and start with chlorine. So I notice that there's 2 on the side of the reactants and only 1 on the product. So what I'm going to do is I'm going to go ahead and place a 2 in this blank. But that affects the silver and the chlorine. So that makes 2 silvers and 2 chlorines. But the chlorines are taken care of. You're going to have to kind of ignore that silver until you come back to it. But you have to go through all the elements first. Okay, so now you have your nitrogens, which are not balanced. There's 2 on the side of the products and only 1 on the side of the reactants. So what you're going to do is you're going to place this 2. Don't forget that the 2 is going to distribute into the silver nitrate. So this 2 is 2 times 1, giving me 2 silvers, 2 times 1, giving me 2 nitrogens, and 2 times 3, giving me 6 oxygens. So this one made a big change. All right, so we've looked at the nitrogens. The last thing we haven't seen is the oxygens. So we have 6 and 6, so that's balanced. 2 and 2 on the nitrogens, 2 and 2 on the silver, 2 and 2 on the chlorines, 1 and 1 on the berylliums. So in reality, we're pretty much done balancing it because it's equal on both sides. So all we have to do is fill in these blanks with a 1. And it is balanced. So this is how you're going to balance it, starting from a word equation and then giving me the symbols, and then last but not least, finally balancing it.